right, so looking at number 3, you've got a ring falling over your magnet. And as the ring is falling down, you can see our force lines coming out of our North Pole are becoming greater. So there's more flux inside here as those field lines get tighter as it gets closer. So it's increasing in the upward direction, or it's positive in the upward direction, which means that the induced field from the ring needs to be in the opposite direction. It needs to be going down. So that induced field, then, what we can do is we can use our right hand rule with our solenoid and take our right hand here, and you can see that as that induced field going down, we would point our thumb down. You can see that the current inside, in this case, would be clockwise as the ring starts to fall over the magnet. All right, now let's address the fact of the ring falling over the magnet down here and out this way. So in this case, what we're going to do is we're going to have the field lines, our B field lines are going to be coming in at the South Pole, and those B field lines coming in are going to be decreasing. So what's going to happen is as they're decreasing, as our ring falls, it's going to fall this direction. Those field lines are going to become farther and farther apart the more it falls. It's going to be decreasing in the upward direction, which means that the induced field is going to be in that upward direction in order to try and do the opposite of what's happening. Because it's in the upward direction, we use our right hand rule, and we can see that the induced current inside of the ring is going to be in a counterclockwise, and this is after it's fallen over. Let's take a look at part D now. Same situation where you have a ring falling over the magnet, but in this case, the South Pole is pointing upwards now. So our field lines are going to be coming into the South Pole this way, and so they're going to be getting closer together. So they're going to be a positive increase in flux in this case, which means that as it's increasing in the downward direction, it's going to be doing the opposite, which means the induced field is going to be in the upward direction. So if the induced field is in the upward direction, we can use our right hand rule. The right hand rule then says it's going to be counterclockwise. Our induced current then is going to be counterclockwise. Let's go ahead and do the last part then, where the ring is going to be leaving our magnet. If the ring starts here and falls down this direction, once again the field lines are going to be coming out of the North Pole. So as those field lines come out of the North Pole, then our ring comes down, and you can see that the field lines are spreading out more, so they're decreasing in the downward direction. So they're becoming farther apart in the downward direction, which means our flux is going down. And so the induced field then is always going to try and do the opposite. And the opposite then would be to try and keep that field going. Because the field is decreasing, or they're becoming farther apart, it's going to want to keep that field going. So the induced current, the induced field direction is going to be in the downward direction, which then we can use the right hand rule again to say it's going to be clockwise induced current inside of that ring.